Hello, everyone, and welcome to today's session, Securing Network Appliances, New Technologies and Old Challenges. My name is Melissa Russell, and I'm the host for today's webinar. Before we begin, I did want to go over a few housekeeping items. We are recording this session, and we will make a copy of the slides as well as the recording available to you here in the next couple of days. If you have any questions during the presentation, go ahead and throw them into the Q&A box. If there's a topic that's right then and there, Paul will jump in and go ahead and address those questions, but otherwise we will save some time at the end for Q&A. At this time, I'd like to go ahead and introduce our speakers. I am joined today by Paul Azadorian, who is our Principal Security Evangelist here at Eclypsium. He is going to be our moderator for today's session. And joining him is Vlad Babkin, who is our Principal Security Researcher. At this time, gentlemen, go ahead and take the floor.
Thanks so much, Melissa. Like Melissa said, I will be moderating, taking questions. If the question pertains to something Vlad is presenting, I'll try and work that into the conversation. And then I'll try and also reserve some time at the end for questions that we didn't get to. Vlad will be doing most of the presenting. I'll just be kind of guiding and mostly fielding questions. And Vlad has some awesome stuff about a set of F5 big IP vulnerabilities. And we'll start with discussing kind of the landscape in securing network appliances. So Vlad, over to you.
Hello, Paul. Okay, so let me start the presentation. So as Paul already said, my name is Vlad Babkin. So I'm a longtime network and web hacker and a web developer as well. So I have been in the industry for like 10 years. I'm also a longtime CTF player. So I played actually for 5 years really actively. And as was already said, I'm a principal security researcher at Eclypsium. And yeah, that's in short about myself. But without further ado, so let me jump into the material. So, and the very first question to ask is pretty much, as Paul said, a little bit of landscaping. How did attacks on network devices even evolve? So in this case, we are not going to speak about like just raw evolution of them, but it will be all through perspective of the attacker, right? So, and the period for network devices attacks, you can actually split into two parts. Part number one is pre-SolarWinds epoch. So in this case, if you look at how often attacks happened, it would be not very often, like maybe one attack a couple of years, like one attack a year, like right before 2019. And major point of that is that attacks were mostly by government groups. Like, for example, VPN filter campaign, for example, all of the noise that shadow brokers made or Vault 7 stuff, right? So mostly you see government entities maybe, or like at least state level stuff. You don't see that many attacks. But then a really landmark event that happened was the SolarWinds attack. It was not really on network devices, but it signified a huge shift into attacks on infrastructure because people started to realize that the infrastructure is really valuable and really vulnerable. So what happens after is pretty much a complete new epoch where many attacks happen, and a lot of them are not even by state entities. It's like just normal crypt kiddies who can weaponize a good vulnerability. Like we have multiple vulnerabilities in the same thing. Like for example, F5, F5, F5. So 3 years in a row there were a new F5 zero day, right? It's not even to single them out because Citrix has a similar problem. Like I do believe there is one more Citrix entry somewhere in here. So then there's also a Pulse Secure vulnerabilities, which were also pretty prevalent, right? And quite a few of them were so simple that they will fit in one tweet. I will show you a screenshot of that. And it got so bad that CISA even issued few directives to actually somehow mitigate all of those attacks and start somehow fixing the problem, right? Because it became apparent that it will not be fixed on its own. So we will touch on that in later slides. But that's my major point. So like you can think of attack landscape as like pre-SolarWinds and post-SolarWinds. And in post-SolarWinds epoch, we do have to worry about network devices. And point is, quite a few of the attacks are actually tweet-sized. So here's one. Specifically, this is in the 5BigIP code execution vulnerability, and it does fit in a single tweet. Like in this case, it's kind of cheating because it's in a screenshot, but realistically, you can fit this much in a tweet anyways. And yeah, many attacks have tweet-sized POCs, and issues in them are your basic web application vulnerabilities. So you would expect that, oh, hey, this is a hardware attack, this is a really hardware device, and the attack on it probably requires a lot of binary knowledge, a lot of reverse engineering, a lot of like binary exploitation and whatnot. But no, the issues are very basic. In this case, authentication bypass, right? And there are quite a few similar issues, for example, with baseboard management controllers. And to be honest, modern devices are in some cases a full x86-64 platform. So it's really similar to your basic server, right? So all of the basic server issues suddenly start to apply to your network device because it's as complex and has as big of an attack surface as a server. So suddenly, a lot of threats become relevant. Because the devices are now much more powerful, you get scripting languages. So, for example, you can have Lua, PHP, or Python, for example, on IoT devices. And we have seen this on many more than one device, actually. So, and many more than one vendor. So this arrives their staple problems. Like, for example, command injection suddenly can happen because those languages are typically just easier to have those bugs in for a developer, right? And we have much bigger devices, like much more bigger and much more beefy devices where you can host a whole database. So suddenly you can get a database injection on a network device, right? And also you have central manager platforms because people no longer want to manage 100 devices separately. They want one place to manage all of them. And we got SolarWinds situation basically because, well, attack the central manager and you got access to all of them. And the best part yet is that you have a full-scale Linux setup on a device with a single user. So it might have just root, and that's it. And everything is root like in the good old times. So you're facing a, like running everything as root is of course the most secure way to run web applications as we know it. So okay, just if anybody didn't hear sarcasm, it is. And
And
yeah,
we still see that today, Vlad, right? Most of
exactly.
these
Yep.
appliances, the web server runs in the web application is running in the context of the root user.
Yep, quite a few of them are. And massive point, like going spoiling slightly ahead, the platform will be dissecting today doesn't really have that issue, but overall it's very common. So it's much more common than you would expect.
Gotcha.
And yeah, in addition to this, you also get a full set of onboard tools. Like before, your device was really restricted by space, like really, really restricted by space. So you couldn't bring all of your Linux setup. So you had a literally locked down Linux simply because you couldn't fit everything. But now, because you have a lot more freedom, a lot more free space on the drive, you don't really remove everything. So the Linux on the device might arrive with attacker tooling, like it might get VGAT, it might get curl, it might get netcat. So attacker gets pretty much free real estate there. And of course, there are no automatic OS updates for packages, for operating system, for anything, normally. Like I have yet to find a device which actually updates like this, but I will not claim that it is every device because your mileage will vary from device to device like greatly. Again, to give more context, where's my mouse? I lost my mouse. Okay, I found it. So to give a little bit more context, you have, so this here are photos of two platforms. On the left, we have a Cisco ISA firewall, and on the right, we have an 5BigIP device. And if you for a second imagine that we don't have this nice Cisco logo here and this nice F5 logo here, you would be really hard pressed to actually tell if this is an F5 device or a Cisco device. It would look like completely like a normal server to you, which has a, in this case, a CPU is visible. I do believe here it's under a cooler. You have a hard drive, you have RAM sticks, for example, here and here. So you have PCI slots. Or actually, this is RAM sticks. Okay, you don't really see PCI slots in this case. Okay, and you have like, all of your normal PC components. So except for some unusual large modules here, for example, it's completely impossible to tell it apart from a normal server, except for the logo, or if you really are a specialist and you can actually tell, oh, hey, this looks like not like a normal server, right? So if you just know a little bit about computers, it will be really hard for you to tell it apart from a normal x64 platform. And that's the whole point. Like, modern network devices are actually that in disguise with some extra hardware to actually facilitate its functions, right? And from the inside, it's still not very different. So I prepared two screenshots for you. And on the left, we have a screenshot from a 5BigIP Central Manager appliance, which pretty much is a completely normal Linux setup with maybe except a few files here and there. Like, for example, this platform update.log is not a normal Linux file, but everything else, for people familiar with Linux, is pretty much just, normal Linux folders. Well, also version file. But on the right, we have a BMC chip. So specifically, this is an AMI Megarak-based firmware. And as you can see, it still looks like a normal Linux setup, but with a whole bunch of unusual files. Like, for example, Redis server is normally not found in the root folder. Or, for example, backup config is also not exactly a normal folder, right? Also, the users owning it are admin and sysadmin. Massive point is that sysadmin for this device is a UH0 user. So you have a chip with like a user renamed to something else. So a little bit more about this chip is that it uses SquashFS. So it's pretty much just an unusual Linux setup, but it's still a Linux setup and still has the same vulnerabilities and the same issues. In fact, we got this shell only thanks to an exploit, right? So normally you don't even see this. Okay, so summing up. Basically, we have a Linux boxes from the 90s, but in 2024, right? I mean, with about the same level of protections, about the same level of vulnerabilities. Attackers do love that because they can sit there for a long time, being invisible and all of that stuff. And it's pretty much a Linux box for which administrator gets no visibility whatsoever because normally you don't even get the full shell. Defender only gets a neat control panel. So like, imagine a looking glass you look through, right? And you don't even have a full shell to actually analyze if something happens with the device. And there are no details whatsoever useful for vulnerability detection or for exploitation detection. So normally you don't even get details on running processes. So it's this bad. So if attacker gets in there, he can sit there for years and years without you noticing. The only way to notice him would be like by activities he makes, which would not look normal on your devices. And that's not great. So you don't get EDR, you don't get any of that. But you have a full Linux box which you don't have visibility into and everything else. So this is pretty much a perfect place to set up shop. Like, it's pretty obvious why attackers pretty much are attracted to this like a magnet post SolarWinds epoch. And yeah, the biggest question to ask ourselves is how do we, in this case by we I mean entire industry, and this can be security companies, can be hardware vendors, whoever is pretty much participating in all of this, how do you fix it? And that's the biggest question. So let's not jump to like our own ideas of how to fix it, but let's take a look at least at a few articles by like, government entities, because these guys are supposed to provide us really good guidance, right? So article number 1, the urgent need for memory safety in software products. So this is pretty much a news article by CISA where they advocate for, oh, hey, we need to have a memory safe software in all of new products, right? And for over half a century, software engineers have known malicious actors could exploit a class of software defect called memory safety vulnerabilities to compromise applications and systems, right? So they write it in a strong language like this, and really beautiful language as well. But the major point is pretty much here. We need to pretty much get rid of C++ for network appliances and for applications that are user-facing. Okay, sounds reasonable. DARPA has about the same idea. So we need to eliminate memory safety vulnerabilities one and for all, And they are trying to facilitate this by translating all C code to Rust. They are trying to automate it, right? So they're trying to pretty much just help people manage all of this. So, okay, that makes a lot of sense. And another guidance from CISA is pretty much secure by design, eliminating OS command injection vulnerabilities. So they also advocate to eliminate issues exactly like from the tweet. So stuff like this, like here, should not be possible. So ideally, modern software should have like basic vulnerabilities like this eliminated, right? So makes a lot of sense. So if you look at this is a good first steps, right? So we do want memory safety, we do want some isolation, we do want to get rid of like C at the core of everything. We do want to actually eliminate OS command injection vulnerabilities. These are obvious goals. Okay, how well will this work? And that's a massive question. Will this even eliminate all of our problems? Will this be a golden bullet, so to speak, or silver bullet, right? Okay, before we proceed, let me dive into a little bit of a side story so that I at least present what kind of devices we're working with. So I have been dropping around the F5 Big IP name for this entire presentation, basically, but I never explained what it is. Well, F5 Big IP is, in short, an application delivery platform. So they provide application orchestration, web application firewall, TLS orchestration, for example. Or they provide quite a few other things as well. So I pretty much just screenshot a couple of features from them. So it's your one-stop shop to deploy a web application, so to speak. And they provide quite a big platform, to be honest. Okay. Their platform got hit with quite a few things. For example, 2022 1388 that was showcased, right, in the post-SolarWinds epoch. And they probably got fed up with it. And in late 2023, they released a next gen of their platform. So the intended use for it is to pretty much use it with centralized management software. And it's a completely right using completely modern technology. So they used Go, they used Kubernetes and all of that stuff to try to get rid of most of their issues and vulnerabilities in the platform, right? So I did showcase a screenshot from the Central Manager appliance. So yeah. So they are using Kubernetes and Go to actually fix quite a lot of their problems. So it's built almost completely based on that. So this is a screenshot of specifically Kubernetes pods running on a Big IP Central Manager platform. And there are about 30 of them. I don't think I fit all of them in a screenshot. And massive point is that many of them are Golang or some public product. Like, for example, let's just read through what we have specifically on the screenshot. So for example, here we have PostgreSQL and Kafka, right? These are public applications. So this is not their self-written stuff. Or they also have somewhere an Nginx container. I don't see it on the screenshot, but it exists. So they use public software, and they also use their own self-written software in Golang. And they have like over 30 microservices, both on the Central Manager appliance. And screenshot from the device looks completely the same way. So if I replace a Central Manager with a Big IP device here, you would not be able to distinguish from the screenshot unless you actually know the internals, right? And massive point is that they actually use a database, and they have an account per pod in a database. So they are pretty much doing a lot of isolation there. Specifically, they're even using separate accounts for every single service, which is, again, very important point. This does reduce attack surface. They have HashiCorp Vault also for storing credentials, so they're not just dropping credentials clear text in the file system anymore, which is pretty much great. So if you think about it, this is nearly perfect follow-up to these three issues. They're not leaving any memory safety vulnerabilities. They are using Golang and memory safe language. They're trying to do isolation and get rid of any command execution bugs possible. So it would be dumb to say that it doesn't improve security posture. It does, right? It really does. But question is, can we still find issues with it? And can we still find something to look at? But before we do this, we need to at least be able to dig a little bit down into the device, because right now it sounds overwhelming. Maybe for the DevOps guy, this is normal, right? You deal with Kubernetes pods all of the time, but normal hackers usually don't, especially on network devices. We're just not used to it. So digging a little bit down into it makes a lot of sense. So in this case, we will be digging down into virtual edition devices, both in the slides and in the demo, but it's no different from digging down into real devices in this case. So real device deployment is just the same thing, but on real hardware. So, and notably, steps for virtual device and central manager are actually pretty similar. So you set up a device, and you suddenly can log in as admin account from the device terminal. So this is an example. So in this case, I did enable SSH for this account. I do believe normally it's disabled. And the question is, what next? So you pretty much have a shell. Also, by the way, as a defender, you can get into the shell, and that's pretty useful. So yeah. Okay. You are pretty much staring at it right now. Okay, so the first command that I already showcased is to pretty much just get a list of running pods. It will just list us every single pod running, like a PS command, right? Okay, it's useful, but not very. We can actually jump into containers using this command. I will not read it out because it's a little bit unwieldy to do so, but massive point is that you can pretty much jump down into any containers this way and into any container for any pod. So notable point is that this will actually not work for Golang containers. So F5 is doing the best practice for Golang, and they're using distrless containers where they only have a singular Go binary, which is, again, pretty great, because if somehow you manage to actually find a memory safety vulnerability in Go, or maybe you find a way to do command injection in Go, you will drop into a container which has literally nothing, and it's not even running as root. So like containers, software in containers is not running as root is the first observation we made, right? Okay, that's pretty good for them. The question is, where do you find container contents and mass? Because you kind of don't want to jump down into every container manually. Well, containers are not magic. So you can find container file system somewhere on the host, and this is the somewhere. So in this case, the path is very long. So it took us a while to actually dig down into it. But once you actually find it, it's possible to list, for example, Go binaries. I didn't screenshot all of them, but as you can see, there is like a fast feature, iRule feature, and a bunch of health check binaries sitting around. So you can actually dig down into container file systems this way and look at what executables exist, maybe pick up a few and disassemble them, analyze them somehow. So, and from here on out, you are pretty much working with normal software, with really good isolation, and running in containers. So from here, it should be enough for an attacker to get started, right? Or for a defender who is analyzing this to get started as well. So in this case, when you actually do defend, you don't want to see how attackers think first, right? Okay, we just observed all of this, and let's just take a moment to think about how attack vectors relate to all of this. And yeah, this destroys a whole bunch of attack vectors. So first of all, as I already noted, command injection is suddenly much, much harder because you are in a whole fleet of containers. Your containers are not running as root. So even if you find the command injection vulnerability, good luck exploiting it, because you might be in a container which has nothing in it, or you might be in a container which has access to nothing useful, right? So even if you do manage to find such a vulnerability, exploiting it is a nightmare. Then memory safe Golang is in use for basically everything. So no more easy binary attacks for you. Again, I'm not very familiar with binary attacks specifically, but even if you manage to find one, good luck exploiting it because you're running in a very good confines. So you will have to somehow escape the container while running non-root and while having a singular binary to play with. You don't have any instant root for any vulnerability whatsoever, by the way. And just thanks to the virtue of using microservices, there will be less poorly designed features. So because microservices do not forgive that, They pretty much force you into a few design decisions that you have to make as a developer to actually to be able to use them. So you will have, by design, less badly designed features. Okay, but does it actually solve all of the problems? And let's just start thinking about it, like which issues do not get addressed by this whatsoever, and which issues appear or should appear in such a platform. And first of all, microservices and inter-device communications with the central manager appliance obviously give rise to server-side request forgery. Like you have to deal with it. It's a bane of microservices basically, and there is nothing from the high level that prevents those issues from existing. Other injections might still be useful. So for example, SQL injections might still exist, even though you will be an isolated part of the database with just a few tables for the service you exploited. SQL injection might still be useful. XSS issues, insecure direct object reference issues, validation related bugs, they all get no coverage from Kubernetes or Golang or whatever other technologies we just named, right? There is also no solution that's apparent for automated component freshness. And to be honest, this list is not even exhaustive, right? So there might be more in a platform like this. So let's see some practical exploitation demos, right? So first of all, this is how the login window into the platform looks like, for which we'll be exploiting. Let me actually log in and just showcase a little bit the platform. Right? So this is what we will be pretty much trying to dissect today. So this is a central manager appliance, and it's pretty much managing, in this case, one device, but normally it will manage more than one, right? And for this device, it gets access to see its version, to pretty much reconfigure it however it's seen fit. So you get to deploy application and it's set up like get logs, set up networking for it, check its health, check its traffic. So a lot of access to the device, right? So, okay. And for applications, you get to pretty much deploy them here, like from application workspace. So you can actually pretty much deploy a hello. And in this case, it failed to do something for an application because I don't have a license. And as you can see, it tried to do something with an application to deploy it on this specific platform, which I just showed it managing, right? So again, no rocket science to guess that if we get access to this central manager, we completely destroy web application, like the entirety of it. Okay, let's think about it for a moment. So I will log out. And the very first vulnerability I'm going to showcase is an SQL injection in the login form. So with all of these journeys through Kubernetes, through Go, through all of the isolation, through all of the memory safety, through all of the user accounts, which are pretty much locking you down, and you just forget the basic SQL injection in the login form, right? Because, let me reiterate this, this is a really simple web application bug, which despite all of the efforts by all of those government organizations to do standards and all of the efforts by F5 to follow those standards, still exists. And let me just show this long injection. So this is a normal SQL injection with one caveat. You cannot really use quotes. So these two quotes are kind of like a magic bypass, which let me fall into the query. But if I use any more, the injection breaks. So I have to use techniques to actually have strings without quotes in PostgreSQL. But that's about it. So there is nothing else preventing me from doing a SQL injection. And in this case, it's a blind injection when I can get something of a single character. But a question in your head, but Vlad, SQL tables are all isolated from one another per service. Well, we are in the login microservice, so it has access to the users table. And we can leak something from the users table. And let me actually run the exploit. And let's see what I can leak. It will start leaking in a moment. So yeah. It's reasonably fast, so we will not be looking at this for like next 10 minutes. Don't worry about that. And what I'm leaking is admin password hash. So I'm literally just leaking the hash for the admin. and not to have it leaking forever, let's see the example hash. You will slowly see it appearing here. In this case, it's a bcrypt hash with a cost of 6. Massive point is that bcrypt with a cost of 6 is a fairly low cost. In this case, the cost is exponential. Recommended cost is at around, I believe, 12 by now, maybe like 11. I don't honestly remember what was the guidance of OWASP most recently for it, but like this is exponentially lower. So this is not twice as low. This is like 2 to the power of 6 as low, and that's pretty much a lot. And this leads to the hash being really fast to brute force. So here
But
is
I just want to go back. How come you couldn't just dump the hash from the guest table in its entirety? How come you had to read it kind of like a couple of bytes at a time?
My massive point is that injection doesn't really give you full output of the query. So it will give you an output.
Your response is truncated, in other words.
Yeah, my response is like, is the user logged in or not, right? So I managed to find a specific response, which in case of bad user account, I can trigger from an SQL injection. And if the user is not found, like in a specific way, I assume that my guess is true, otherwise it's false. So like specifically, I have an if here, which will output the username, or yeah. So like, yeah. So in this game, in this case, I'm comparing the username to whatever I provided. So in this case, I'm attacking the admin. And in this case, I'm also have a condition to check if password matches my guess. So I'm doing two conditions. Username is admin by default, like target admin. You might specify another target user. And my password matches my guess. In this case, I'm doing one result. In the other case, I'm doing the other result, right? And this is how I can distinguish between the cases. But I don't get full query output, so I cannot really do a union injection or something like this.
Okay.
So I do have to do a blind injection. So this injection took me about a day to craft. And again, a little bit on this as well. It might be possible to craft an injection which doesn't even need me to leak a hash, right? I'm in the login form. If I manage to craft a condition in a SQL injection, which will trigger the bypass, so for example, which will let me bypass the login form, I might not even need to leak the hash. I might just get a user session right here and right here, right? But crafting such an injection proved to be difficult. So we cannot prove it impossible. So a really persistent attacker who really wants to break in might be able to do it, but we didn't. In this case, like it took a little bit too long, and I decided to stick with the password hash leak because it was a really stable injection. It, by the way, finished while I was explaining it. So
Nice.
it has one more character to leak, right? So it's very practical, and consider that this is running over VPN. So yeah, it's very practical. Point is, like you look at character by character, and massive point is that brute forcing it is relatively fast. So this is a brute force of this hash on two 4090 cards. So this this like setup is not big. So just two 4090 cards is not a lot. Normally, an attacker will have a whole farm of those, maybe like at least 8 to actually brute force the hash. So the attacker will get a lot more than 100,000 per like more than 200,000 attempts per second. So consider that the real attacker might get millions of attacks per second. And again, FPGA, bcrypt. There's also these guys who built a wall of FPGA gates for cracking bcrypts at a high speed. I don't know what kind of work factors they used for their testing, but they had a huge performance boost from FPGAs a long time ago. So when GPUs could like do maybe like 7,000 for a work factor of 7, right? And slightly more for a factor of 6, maybe like 14,000. They had a 120,000 for FPGA gates, and they created the 12 FPGA boards to brute force hashes really fast for bcrypt, right? So you can actually build a full FPGA board which will consume like 585 watts and reach a 2 million password per second at a work factor of 5. So the same setup will reach a million with a fork factor of 6. So for just 600 watts of energy. So you can build a whole FPGA board for this. And that's from actually a while ago. I don't know. Yeah, it's from 2020. So in the past 4 years, those probably became even faster. So yes, you get millions per second realistically.
Mhm.
And for not a lot of electricity. So you don't have to actually, crank up your electricity bill for running a 4090 for this. So again, this is an interesting attack point, like from economic perspective. Also, there's not one injection, but 2 injections in the login form. So the first injection that I showed was in the provider name field, but another injection is in username field, and it's a so-called OData injection. So to actually detect language for this, like I actually had to use AI. So I managed to guess like a couple of syntax components for it, and I couldn't Google for it for a long while until I just decided to ask ChatGPT, oh, hey, what languages have this and this and this and this syntax components? And it pretty much just came up with OData, which actually fit. So we have a weird language injection which allows for the same byte by byte password hash leak. In this case, the limitation for this attack is that your device must have LDAP integration enabled. By the way, for SQL injection, you don't have any such limitation. So yeah, it's pretty much a worse version of SQL injection. So once you actually break the hash, so it's really important to have a strong password for you to have at least basic form of protection. Like you get full access to the admin interface, right? So you pretty much can, once you have the password, do this as an administrator, right? I do know the password, but if you brute forced it, you also know the password, right? Okay, this sounds great. But let's say the admin got informed that he got attacked somehow, maybe through some network detection, maybe through some integrity solution, maybe through something, right? Or he just suspects that he wants to update the platform and rotate his password regularly, etc., etc. So you as an attacker might be hard pressed to keep your persistence this way. So you need another attack. Like you don't really have code execution yet. Okay, what other attacks exist in this case? And the attack I'm going to showcase is also pretty interesting. What we found out is that when you actually communicate with the device, actually I can show it live because why not? So when it actually communicates with the device, so I'll open a development tools in Chrome. And if you pretty much look at the requests that are done by, in this case, JavaScript, we will notice that it has stuff that looks suspiciously like links inside of headers, right? So you are pretty much just doing a IP device v1 proxy, and you do a pass on the device, which is /systems, right? So this starts to look suspicious for you pretty darn quickly. Like we were just talking about SSRF being a potential surface, and you just take a look at the device and see, oh hey, so it does some proxy into the device by using a pass that the user defines. But what if the user defines some pass that's not intended to be used? So when you set up the device for use with Central Manager, it removes every single user from the device, but one that's intended to be used by Central Manager itself. This is a point. Again, this is during the setup of the device, which is a process that took me about 2 hours. So I will not repeat it here. But I'm just quoting this one step, which was very important. And in this case, if someone could make a user on the device, Central Manager will probably not be aware of it. It will not show up in the UI. So you will have a really stealthy persistence, which the admin will have no visibility into, except for the case when the admin exploits the same vulnerability. So this is a pretty massive, right? And what we did is we find such an endpoint, and it was named not very prosaically /users. And you can actually make put requests as well through that same proxy method, right? So I'm just proxying /users to the device, and I can make a user. So in this case, I'm making a user with a random password. Let me showcase it working. So we are attempting to make a user on all of the devices managed by the Central Manager. One point is that this attack actually needs admin password login, or maybe it needs to abuse a bypass way to exploit the injection, but it needs some kind of access. Like it's not pre-authenticated like the SQL injection that I showed, right? So it will try to make users on all the devices managed by this platform, and it will try to make this user on this device. So it pretty much pulls this IP address from the central manager, and it's pretty much testing device login test and succeeding. So it's getting a token to use with the device. Okay, let's see at least something that we can do with this. So I have a way to log in on the implanted device, and as you can guess, there is already a couple of users created because we did this attack quite a bunch of times before on this one device. But let's use the users that we just created for pretty much clarity of the situation, and let's run this. Let's just see how it pretty much logs in using this. I'm calling this shadow users, but it might be a bad name, right? So, okay, so I pretty much logged in onto the device. I got information about its platform. And then for the demo, I just dumped a bunch of log files. But keep in mind that this user has full admin access to a specific BIG-IP device. And even if admin right now went and changed the password, and even if admin went ahead and patched the platform, even if admin pretty much made his due diligence to actually, evict all of the users from central manager that he can see, this user I created will still be left. Because the only way to actually see those users and delete them is through the exploit. And which is pretty massive.
So the SSRF vulnerability lets you create users that don't show up in the interface.
Yep, they don't show up in the interface anywhere. Again, you can browse this however much you want. So there is just no users here.
Yeah,
so
because
there's
it's a
no
different
place for them.
it's a different API endpoint essentially that you're using to
Yep.
create that's not
Yep.
linked back to the management console.
Yep. And admin using the same exploit, again, I'm using the same exploit, but I created a GET request to the same /users URL, right? I can just run it and dump a whole bunch of hidden users. So
Right, I gotcha. Yeah, so you can query it because you know the API endpoint. Yeah.
Yep, I have the exploit. Like this is the exploitation. So this is the only way to detect them, to my knowledge. Like I didn't find anything else, and that's pretty much the only way, right? So yeah, that's pretty much the way to actually use the exploit legit. So as a defender, however crazy as it might sound, you are often forced to use exploits to check your device for vulnerabilities. Like, just think about it. You as a defender, your only visibility into the device, like, your only visibility into the device as a defender is through use of exploits. Just take a moment to think on this.
That's awesome.
Like this is completely insane, and this is not just this one device. This is something we observe constantly, right? So this is not the way to defend, just in case. So, and again, not to single out F5, this is by far not just for F5. And let me show you something. So I'm done with pretty much the exploitation demo. So this is pretty much short descriptions for vulnerabilities. I did very long description for 4 vulnerabilities out of 5. So 2 of them got CVEs, others didn't get CVEs. And you might question, why didn't they get CVEs? I will come to this in a moment. So for now, just think that they don't have a CVE number. And there is one more vulnerability which I didn't describe, but which is still pretty bad. Admin user can reset his own password without knowledge of his current password.
Yeah.
So this is not the way to do secure web applications. So this is not great. So if you leave your computer unattended, somebody can just go ahead and willy-nilly change your password. So Web UI will not allow you to do this, but it's actually possible. Like we did this through, again, source service Python, right? So it's not an obvious attack in this case, but it exists. And to my knowledge, these 3 vulnerabilities did not get a patch. So the latest version of BIG-IP Next had these vulnerabilities at the time of making this presentation, right? So I didn't check in the past, few weeks. So they might have patched it in the Fallout, but I don't know. They might not have. So they don't really consider this a vulnerability. Okay, and a bunch of conclusions. Biggest conclusions of them all. Every single vulnerability showcased falls into a well-known category from OWASP top 10. So specifically, we have broken access control, cryptographic fail, injections, and SSRF.
Yeah, I was thinking the same thing when you said that. I'm like, everything Vlad's describing, I'm like, I'm pretty sure that's on the OWASP top 10 list. Turns out it is.
Yep, it is from OWASP top 10 list. And that's a massive point. We have OWASP top 10 vulnerabilities, top 3, by the way, and the top 10. So top 10 should be top 1 for microservices, in my opinion, but that's my personal opinion. I will let it be top 10, right? And additionally, all of microservices do depend on something. So they do have libraries. And if we had full access to BOM, we would be able to check this easily, but we don't. So we cannot verify if there are any library issues or any CVs associated with like installed software because we don't have a full bill of materials for it. So software supply chain playbook should apply in full here, but it really doesn't because we don't have BOM. So this is another standard which we should follow, but we don't. You don't have BOMs for most hardware like this.
With the access that you have to the devices, though, could you create a bill of materials for those containers, Vlad, using, there's a lot of open source tools that'll do that.
Yes, I can. But massive point is that getting access to this container is kind of a hacky way to do it.
Yeah,
Like
yeah,
as
sure.
an administrator, you will
Yeah, you're
not
probably
normally
not gonna
have
do that.
SSH shell. So
Yeah.
you're not gonna do this easily. As a researcher, I can, but like I didn't because like I mean you have OWASP top 10 already. I just didn't dig too deep in this case. And this showcases just how complex the devices are. Like we have all of this on a seemingly simple platform. It's actually much more complex underneath than you can imagine. And with this complexity arises stuff that we didn't see before. Like if you scroll back like 10 years, and you probably will not have any SSRF issues with the devices simply by the virtue of devices not having microservices. Like there's just nothing to SSRF in them, right? There's just nothing running. You cannot do SSRF when there is nothing to SSRF too, right? So that's it. That's pretty much the conclusion for the exploit. And key takeaways is that many of the past vulnerabilities could have been prevented with better approach to software engineering, like which multiple vendors don't actually apply to firmware level tasks. So again, there is no standards for this security, and people just do whatever they want. Like Big AP just read a bunch of these articles, I presume, and thought, okay, let's follow that because like we got bashed really badly by vulnerabilities, we got a lot of bad publicity, let's get rid of it. In the meantime, our platform also needs an overhaul for whatever reason. I'm just simulating in here, so I don't know what went through the head of the engineering team. It might have been not even related to security. They might have just decided to improve their platform by a lot, because again, this is a quality improvement that I showed to you. Like it's qualitative by a large margin, but like such a haphazard improvement didn't cover everything. We just saw it an example of a really good attempt to do this, right? So this is not a like random device which didn't get secured yet again. It's a device which actually tried to stay secure really hard. Because they didn't really apply standards, because there are no standards, it didn't work. And vendor response. We reported all of those vulnerabilities, and Eclypsium findings for which we did not issue CVEs cannot be directly leveraged to impact the security of the product and require an attacker to first have highly privileged access. F5 does not consider these to be vulnerabilities and therefore did not issue CVEs. We have a situation where a vendor can bona fide say that OWASP top 10 vulnerability is not a vulnerability because it needs high-level access.
Yeah.
And there is nothing we can say to them. We don't have a standard to point them to.
Yeah,
So,
I mean, I don't agree with that decision. I'm sure there was reasons that went into that decision, but I think it's important to point out that the pre-authentication vulnerability was the SQL injection, and that was acknowledged by F5. But the server-side request forgery, which was the second part of in your exploit change that allows you to create users that are invisible to the management interface, was not fixed. And I think that's an important distinction to make.
Yep, and it was not acknowledged. So in this case, we are in a ridiculous situation where vendor can do this, and we cannot really tell them anything, right? This is of course their platform, but point is, if you could point them to some kind of NIST standard to actually follow, it would make our discussions easier. But no such standard exists. And in this case, due to lack of standards, vendors can do this. And again, I'm not trying to single out F5 here. This is not the first time such a response is received, right? In this case, it's just in context, it looks like you're just bashing F5 for no reason, but no. In this case, it's a very common thing that you can see. And overall conclusions are, well, isolation, memory, safety are good and won't fix everything. There are still a lot of basic vulnerabilities present, even if you apply those. We need more tools and approaches from software supply chain playbook applied to firmware. And F5 actually did improve security by a lot. Like, they actually did improve their security posture, and getting a full host level code execution will be impossible. Or at least will be much, much harder, because now you will have to pretty much break out of the containers. You will have to privilege escalate, probably using kernel exploit, even if you get some kind of OS command execution, etc., etc. So it will be much more involved than the one tweet exploits that they had before in their big IP platform, in their previous generation one. So their security are much better. So that's pretty much it. Any questions?
So, but I mean, Docker container escapes in particular, there's been several documented over the years. Is that something that you just didn't haven't gone down that path yet? Is that something that you believe could be possible on this, similar platforms to F5?
So it depends on how you use Docker. So a lot of those escapes implies that you have some kind of root user in the Docker, right? In this case, you don't. So first of all, you need to get root user. So you need to privilege escalate within container probably. And then you will have to use kernel exploit or some Docker escape to actually bypass it. Yes, it is possible, but it's not going to be easy in case of F5 simply because they configured it correctly. But no, Docker on its own will not fix your problems. So if
Yeah,
you do,
it's like Chrome exploits today. They say you have a working Chrome exploit, but it's really two or three vulnerabilities that are intended to get you to the next stage in the game, right? You've got to have one vulnerability that you priv escalate into in Docker, then you've got to have another exploit that gets you out of
yep,
Docker, right? So it's
yeah,
a series of
yep.
vulnerabilities and exploits that get you there.
Yep. And then again, a lot of dump stuff can be done with Docker setup. So if you, for example, mount container root file, host root file system in the Docker, by using Docker in this case,
Right,
like
right.
if you have access to root file system, for example, that's GG. So there are a lot of ways to actually set up Docker in such a way that it will fail to actually confine the attacker, right? So bearing a badly set up Docker, bearing like root in the container, you will need a whole chain of exploits, right? So it becomes much more involved very quickly.
Is that using Docker volumes as opposed to mounting local file systems as part of that defense, right?
Yeah, you try not to mount local file system as much as you can. So, or you try to mount a benign folder, so to speak. Like you can have a folder specifically for this container, which only has its own files. So
Right.
Docker volumes are secretly also a folder in the file system,
Yeah.
just a folder that's not pointing to anything important.
hmm Outstanding. I don't see any questions. If anyone does have questions, I'll give everyone a minute or so to do that. Ask any questions that you might have.
Yep.
There was one question that came in earlier, and I just wanted to reiterate it for anyone who did join us late. We did record the session, and we are going to be making a copy of the slides and the recording available. You should be seeing an email from me here in the next day or so with links to both of those.
Awesome. Vlad, I do want to point out that one thing that I gleaned, and this is based on some side conversations I've been having with other researchers as well, is that oftentimes when we lift the covers on these devices and appliances, we find a really old Linux environment, right? That is just spread like rife with privilege escalation. normally not that big of a deal because you need some kind of way into that device through a web application. But as you pointed out, as some of those other fronts start to get hardened, some of those privilege escalations could now be in play. Like typically on IoT devices, as an example, the web server runs as root, so I don't need to privilege escalate. But now you might have to. So I think it's a word of
Yep.
caution to make sure the vendors are applying those patches and updating the underlying subsystems.
Yep. You like as a vendor, you want to pretty much have a kind of privilege separation, even if you don't really want Docker on your device or your platform, even if your platform doesn't really have resources to facilitate having Docker, it would make a lot of sense to run your web server as a non-root user, for example, because now if somebody manages to exploit that web service, they will have a slightly harder time to actually get your device, right? They will need to privilege escalate somehow. So even if you don't really do like all of the container isolation, you can still do normal Linux hardening by having like separate users for your services. So it still applies.
Awesome. A question did come in, how to protect OT devices using Docker. Have you seen, Vlad, embedded platforms using Docker within some of these platforms like on OT?
So important point is that like this is the first time I even see something like containers in use on a network device. So again, this is very important point. Like this is one of the very first cases where we actually saw Kubernetes or Docker in general in use on a platform like a network appliance, right? So normally you don't see it. As per how to protect it, well, you use it. I mean, you can run quite a lot of things inside of yeah. You can pretty much use it.
Yeah,
You
I
just
haven't.
use it and you do best practices for it. That's
Yeah,
very
I
important.
haven't encountered on a lot of the devices that I've looked at. I have not encountered Docker. In some cases, I have seen some extra protections, like some Linux security software. But I've only seen that once on one platform that I've looked at. I have not seen Docker. If it is in use, we haven't come across it yet.
Yeah, I see a question that's, was the session restriction initially restricted, or did you remove this restriction? What kind of session restriction you are talking about? Because like I don't get the question quite yet. And I see in Rail it's used. Okay, so not the first example, well, second then. You don't see it often, that's for sure. So yeah. At least, well, you see the Docker often in modern software, you don't see it on devices in general.
Yeah.
Like some devices might use it, which we didn't analyze because like I'm a singular researcher, right? I cannot analyze every device in existence. So there probably are others which do this.
Awesome.
Great.
Well, I know we had that question that needs some clarification, but feel free to contact us and we can have a discussion.
Yeah.
Because you'll email all the attendees, right, Melissa? So they can always respond to that email and we'll get the question
That is
answered.
correct. At this time, I'm going to go ahead and, oh, wait a second. There was one more
What
question.
about
I think
using?
we have 1 more minute if you guys want to address this last one that came in.
Oh, okay. What about using SE Linux instead of Kubernetes Go? That's the approach chosen at Cisco for iOS XE devices. Latest release is now SE Linux enforcing mode. That's also a good approach. So I wouldn't say that Docker is the only way to do isolation. So if you actually isolate your services in another way, like for example, you run them with a specific user, you run SE Linux to enforce certain restrictions on system calls, it's still pretty good.
Yeah.
Like, I mean, I don't know if it is as good, but it is very strong if you actually enforce it correctly. I mean, as with Docker, you can have a SE Linux which has pretty bad restrictions. Like, it might not restrict you good enough to actually, for example, you have a restriction where you're allowed to do system calls, right? And like by system call, I mean something like system from C, right? You can just run whatever command you like, and suddenly all of those SE Linux shenanigans makes no sense. But if your restrictions are actually good, like your setup with Docker has to be good for it to be useful, same here. If your Linux setup is actually good, it will pretty much force attackers into a pickle where they have to actually pretty much do work to actually do some exploitation.
Mm.
And yeah, so best practices and analyzing devices from time to time. Yes, again, as a manufacturer, yes, you need to have a best practice. You need to have a regular pen test cycle. You need to have some review. You need to have some security in your SSDLC. So because like if you don't have security in the software development lifecycle, it will be like constant game of try to patch all of the vulnerabilities you just randomly find. So the more left you can actually start, the better. Like, for example, like let me give you an example of a decision that you can make very early on. So Eclipsum platform, we don't really have a default password. We started with doing random password like right away, and this prevents us from having a default password. So we don't have a way for like an attacker to actually have an admin account simply because we don't really have that account anyways. And that's just a minor example. Or for example, if you start developing your web UI, you can have a very restrictive content security policy right away. And if your developers follow it, it will not take their time to actually later down the line slap it in a year later into the development process, simply
Yeah,
because it will
that's
be
a
there
great
from
point.
the start. So the earlier you can start with a security best practices to prevent all of those issues, the better. So like if you can start with SSL Linux in enforcing mode when making a new device, do it. It's better to have a very locked down environment where you have to punch holes to allow you to do some things that you must do for this device than it is to pretty much confine a device which had no such restrictions for a couple of years and now has to be enforced. So it will be just so much easier to do this.
Awesome.
So
Good
the
stuff.
earlier you can start, the better.
Well, at this time, we have hit the top of the hour, and I want to thank everyone for taking time out of their day to join us. Thank you both, Paul and Vlad, for the great presentation. And to everybody in our audience, we look forward to seeing you on the next webinar. Thank you so much.
Thanks, everyone.
Yep. Thank you, guys.